When you hear 10th grade AI class, what's the first thing that pops into your head? Probably a screen just filled with lines and lines of complicated code, right? Well, today we're going to pull back the curtain on what's really going on in these classrooms. And trust me, it's about so much more than just programming.
So what are they actually learning in there? If it's not just about syntax and algorithms, then what's really at the heart of AI education today? The answer might surprise you. It's less about turning them into master coders and more about teaching them how to think, how to spot a problem, dream up a creative solution, and then actually build it from scratch.
At the end of the day, these students are learning how to tackle real, tangible problems. They're not just doing abstract homework assignments. No, they're being given a structured, step-by-step guide to take an idea from just a concept all the way to a real-world solution. And that guide, it's called the AI project cycle.
Now, this project cycle isn't just for a school project. It's the exact same roadmap that guides basically every AI endeavor, whether it's in a classroom or at a huge tech company. So let's take a look at the steps.
Okay, here are the 6 key stages. It starts with finding a problem and goes all the way to releasing a solution out into the world. Now, every single step here is crucial, but we're going to zoom in on a few that really show how these students are learning to think. Scoping the problem, building a model, and then figuring out if it even works.
Everything kicks off right here with what is arguably the most important step of all, problem scoping. Because look, before you can build any kind of solution, you have to get what the problem really is. And that means you've got to ask the right questions.
To do this, they use a really cool tool called the 4W Problem Canvas to dig deep. They ask, who does this affect? What exactly is the issue? Where is it happening? And, the big one, why does this even matter? Answering that why question forces them to think about the real-world impact. Everything from the ethical side of things to whether their solution is actually sustainable for the planet.
So once the problem is defined and they've gathered all the data they need, we get to the really exciting part, teaching the machine. This is the modeling stage, and it's all about picking the right strategy for learning.
The first approach is called supervised learning. This is where you feed the AI a whole bunch of data that's already labeled with the right answers. Honestly, the best way to think about it is like studying with flashcards. You've got the question on one side and the correct answer on the back. The AI just goes through thousands of these examples until it starts seeing the patterns.
But, what if you don't have all that nicely labeled data? Well, that's where unsupervised learning comes in. Here, you just give the AI a massive, messy, unlabeled data set, and you ask it to find the hidden patterns all by itself. It's kind of like dumping a giant box of mixed-up Legos on the floor and asking someone to sort them by color and shape without ever telling them what the categories are. So, to put it simply, supervised learning is amazing for sorting things, like figuring out if an email is spam or not spam based on past examples. Unsupervised learning, on the other hand, is all about discovery, like a business finding totally new ways to group its customers based on their shopping habits.
And then there's the third major type, reinforcement learning. This is all about pure trial and error. The AI tries something, if it's a good move, it gets a reward. If it's a bad one, it gets a penalty. Do that millions of times, and eventually it learns the best strategy. This is exactly how an AI learns to master super complex games like chess or Go.
All right, so you've built a model. How in the world do you know if it's any good? You can't just cross your fingers and hope for the best. You have to evaluate it. This is where the AI gets its report card to see if it actually passed the test.
One of the main tools for this is the confusion matrix. And I promise, it's not as confusing as it sounds. It's just a simple table that compares what the model predicted with what actually happened. It clearly shows you all the times it got it right, the true positives and true negatives, and separates them from all the times it made a mistake, the false positives and false negatives.
And all that detail in the matrix, it gets boiled down to a single, really easy to understand score. From those numbers, students can calculate things like accuracy. So in one example from the curriculum, a model for spotting plant disease scored an 82.5%. That's its grade. It's a B-. Clear and simple.
Okay, so once a model has been built and we know it's effective, there's just one final step, deployment. This is all about taking the project out of the classroom and getting it ready for the real world.
And this is where the curriculum makes this really cool connection between AI and entrepreneurship. Students learn that launching an AI solution is a lot like launching a startup. You have that initial entry stage, then a survival stage where you're competing, and then hopefully a growth stage where the whole thing just takes off.
So when you put all of this together, what does the skill set of a modern AI student actually look like? Well, it's this really rich mix of both the technical and the practical.
What the curriculum builds is this incredibly well-rounded skill set. I mean, of course, they learn the technical stuff, AI modeling, computer vision to understand images, and natural language processing to understand text. But, and this is so important, just as much time is spent on ethical analysis, communication, and that entrepreneurial mindset. It's about creating responsible innovators, not just people who can write code.
You know, this quote, which is taken right out of the curriculum self-management unit, really just says it all. This type of education isn't just about learning a new technology. It's about giving students the tools to thoughtfully design their own futures.
And it leaves us with a pretty big question. As AI keeps weaving itself into every part of our lives, the skills being taught in these classrooms, problem solving, ethical thinking, creativity, they're becoming essential for everybody. So what new skills do you think we all need to be learning to really thrive in this new world?